Okay, so for this problem, for finding an area of a region enclosed by two curves, I'll start by graphing the two functions. I'm using a graphing calculator that shows me that the y is equal to x squared minus 6x. Looks something like this. And then the negative x squared plus 2x looks something like this. And they cross here at x is equal to 0 and here at x is equal to 4. So that gives me my lower bound and my upper bound being 0 and 4 of my x values. And then when I'm finding an area of a region enclosed, I always want to set this up as the top region minus the bottom region. So the top region is this one, the top function I should say. The top function is the negative x squared plus 2x. So we put that down first, and then we subtract out the bottom region, which is the x squared minus 6x dx. Okay, I didn't really set up my brackets very well there, but that's okay. So yeah, we can simplify this to make it the integral from 0 to 4 of, we have a negative x squared and then another negative x squared. So that makes negative 2x squared. And then a plus 2x minus a negative 6x makes plus 8x dx. So now evaluating this integral is negative 2x, or taking the integral I should say, add 1 to the exponent, divide by the new exponent, plus 8x, add 1 to the exponent to make that should be a 2, over the new exponent, which is a 2, evaluated from 0 excuse me, to 4. So then plugging in the top makes negative 2 times 4 cubed over 3, plus the 8 over 2 goes to 4. 4 times 4 squared. And then minus, plugging in the 0 will just make 0. So then simplifying, negative 2 times 4 cubed. 4 cubed is 64, times 2 is 128. So that would be negative 128 over 3, plus 4 squared is 16 times 4 is 64. So then simplifying, 64 with a denominator of 3 would be 64 times 3 is 192. So this is negative 128 over 3 plus 192 over 3, which 192 minus 128 is 64. So that would be 64 over 3, which is our answer.